Hello. My plan for today, if I'd come in, was to tell my little full moon story here. Um, for us to go over the data that we're collecting about math, why people hate math. Right? And I'm using a shorthand there. I don't mean that at all, but there's something special about the relationship that students have to math, and I'd like to isolate some of those. Um, some of those are based on our personal experiences, and some of those are more generally known and conjectured. Um, and then my intention was that we would go to the Pearson website and sign up. No matter what your finances are, you have 14 days to get that organized and to talk a little bit about what the college has to offer or the university has to offer about support for special circumstances. And then that would take us to the end of the hour pretty close. Maybe talk a little bit about percents. So we're going to delay the Pearson part until Wednesday. I will bring in a form that has registration instructions. Will take some time for you if you choose to register right there in class, whether you're paying or not, so that we can kind of go over Pearson a little bit and I can answer questions. And we'll talk a little bit about percents on Wednesday. So for right now, we'll just talk about the moon. I really had in mind two stories or two ways to talk about the relevance of math. Now, when, for example, I'm when I get to teach a calculus class or a pre-calculus class or a statistics class or a linear algebra class, it's understood by all. What is the value of mathematics? Maybe not this mathematics in particular, like why do I have to take calculus? That may not be clear, or it may be clear. I'm never going to use calculus, in my professional life. Why do I have to take calculus? Okay, that's all fair. But there's an understanding among STEM students that mathematics is powerful and valuable. Understood. So it's a little bit different to say, now, why are you being coerced into taking mathematics class, right? Your major is very likely not STEM. In a STEM field, you'd be taking a ton of other math classes. If that were the case, that's a reasonable assumption. But nonetheless, university is requiring that you take some mathematics before you graduate. And maybe you've taken this class, or you selected this class because it says, well, it's a mathematics, a personal finance, and I'm going to be dealing with personal finance issues for the rest of my life, so maybe I'll learn something useful. And it is possible that you learn some things that are useful, but just talk to my colleagues up on the third floor here in Morgan in the business and accounting disciplines, and they will tell you there is a lot more to it than whatever is happening in this. So you're not leaving here, this class, with the ability to do your taxes in a complete way when we talked a little bit about taxes, or to really understand the subtleties of the insurance business, or even how credit works and the subtleties of that, or investing. There's there isn't anything that really is going to be in depth or complete. So I'm going to sell to you my one of my rationales for mathematics across the curriculum, and my feelings about it. So first of all, just so you know, I have a hard time using mathematics in my regular life, in my non-academic life, when I'm writing papers or doing research, of course. Mathematics is what I do. But when I'm just doing things, it's hard. It's really hard. Um, and by mathematics, I mean sort of the professional end of my discipline, not calculation and estimation and those sorts of things, not specifically talking about that. And that's not where I see the real value of you in this class, or why the university would say it makes sense for everybody to take a math class before you are awarded a diploma. So why the full moon, and what does that have to do with anything? Well, let's see, 2,500 years ago, approximately, Aristotle wrote a series of books and established the foundation of not just Western philosophy, because Aristotle was taken by the great Islamic thinkers in that pan-Islamic civilization, about 800 Common Era to maybe 1200, just roughly that time, that stretched from roughly Spain to Malaysia, something like that, that entire belt. And was just an incredibly intellectual, intellectually rich time. Aristotle was taken as a text by those thinkers, by the thinkers of that civilization. So not Europeans by any means, and revered and recognized as a powerful thinker. So not just the European tradition, and not just the Western tradition. So we're talking about thousands of years, generations upon generations of some of the most brilliant people, using Aristotle's works to understand the world around them in many ways. One of the things that Aristotle proved logically and beyond any doubt was that objects in the heavens, meaning anything not on the earth, objects in the heavens, were perfect spheres. He proved that from first principles, or at least in his books. That's what his claim was, and this was accepted. That the planets, the sun, the stars, they were themselves perfect spheres, unblemished, meaning that there was no deformation in them. The coloration, not entirely clear. What I'm not entirely clear what the explanation was, if there even was one offered. But the moon was a perfect marble. Maybe it wasn't a one-colored marble, but it was a marble, a ball bearing. It was perfect, and perfect in the sense of all caps, large font. Perfection, because that's how things happened in the heavens. In the celestial realm, things were perfect. And Aristotle didn't just say that because I'm Aristotle. Gave an lengthy, detailed arguments why it had to be. He also established, or claimed that he established, that the paths of the planets were perfect circles. Not approximate circles, not wobbly circles, not slightly deformed, but nearly circles, but perfect circles. Everything was perfect. Had to be perfect. So this was simply what people saw, or how they interpreted what information came in through their eyes into their brains, what they literally saw. They saw that the moon was a perfect marble, a perfect sphere, the sun, the planets, all perfect. They perceived that. They interpreted the sense data that they got through their eyes via that lens. Well, so Galileo, an Italian scientist in the 16th century, uh, found out about this new invention, the telescope, and said, "This sounds great. I'm going to make one." He made himself a telescope, probably not as strong as a pair of binoculars that you would buy just in the, just not a serious pair of binoculars, but just a pair of binoculars that you might buy uh, relatively easily. Nothing very professional by today's standards. And he looked at the moon with this telescope, and he said, he looked at this image here, the image that you're looking at, the moon that we look at, and Galileo said, "Wow, Aristotle was wrong. The moon is not a perfect marble. It's not. It has craters in it, has holes in it, and it has mountains on it. It has deformations. It's not perfect. It's like the Earth. It's got mountains and valleys and all kinds of structures." And now, again, I want to emphasize, if you're looking at this image, which is a pretty good high resolution image, I think I got it from Scientific American, you can't really see mountains or valleys. We see those dark spots, and now we interpret them in our brains, our minds. We see dark, and we say, "Oh, those are craters." Well, that's because we have grown up, or we have been um, fortunate to have that information, and then we interpret what we see, these splotches, as craters, for example. Galileo didn't have that. He had to actually deduce that what he was seeing was contrary to what had been held as absolute truth for thousands of years. And how did he do that? Well, here's my argument. All right, Galileo's a scientist in the Renaissance in Italy. And how was he able to understand what he saw? Well, astronomy as we know it, an understanding of the planets, the sun, the moon, stars, anything, there were no texts. He was, in fact, one of the authors. He was creating our understanding of modern understanding of the solar system. So it's not as if he was able to look in a book and say, aha. There were no modern astronomy books. His understanding did not come from astronomy because that didn't even exist. It came from somewhere completely else. So he was a student. He had been a student. In the Renaissance, and he got a liberal education as it was understood then. He studied ethics and philosophy and mathematics, but part of his curriculum was, especially now this would be in Italy and in the Renaissance, was this new bit of knowledge, an exciting bit of knowledge that was being developed there, and that was perspective drawing. So as part of his liberal arts curriculum, or liberal curriculum, he would have had, reasonably, we can hypothesize, he would have had this exercise, which students today in drawing classes typically have also. He would have gotten a lump of clay. In his class, his fellow students would have gotten a lump of clay. They would have poked holes in it and made little blobs on it, little mountains. And there would be a candle illuminating all of this, or maybe at an open window during the daytime, or at a window during the daytime. And then he would use these new ideas of perspective and innovations in drawing and in representing the world, 3D world in 2D, to shade and show three-dimensionality in a two-dimensional, on a two-dimensional plane, on a piece of what we would say paper, but whatever canvas he was working on. So as a student, let's say let's look at his situation. I'm just making up this story. I want to be an astronomer or a scientist. Why do I have to take a dumb art class? That's so dumb. I'm never going to need art, in my work. I'll get somebody to draw my, illustrations. I don't want to do it. I don't make time for this. And it's all stupid, and artists are weird. And, it's a waste of time. I want to do math. I want to do more math, and I want to do more science, right? Why do I have to take art? And then the university says, well, we won't give you a degree if you don't take an art class. And he's just like, okay, fine, I'll take an art class. So he takes his art class, and so he takes this, he has this knowledge, and then later, years later, he builds his telescope. He looks at the moon through the telescope. And because he had some training in art, maybe only some small amount of training in art, he was able to process that information and think differently. He was saying, you know what? This is just like my art class. Oh, the moon is not a perfect marble, right? And so for many of you, so that's kind of my story. And for many of you, it's the exact opposite, the converse of that. I want to be a visual artist. I want to be a writer. I want to go into social work. I want to be, I want to study history, or whatever it is. Why are they making me take these dumb math classes that, are useless and are just wasting my time? And to some extent, I'm going to say, yes, I agree. Just as Galileo probably didn't use a whole lot of drawing skills in his work, or could have just gotten a consultant to do his illustrations for him. Sure, it's not that. It's that he could think in a way that turned out to be useful. So that's what that's my hope, that we are able to take away from all of the the graduation requirement classes that don't fit into our major, is that there's a way of thinking that may be valuable professionally. It may just be enriching. It may just be curious. But that's just the point, is that if we have no experience in thinking beyond our disciplines, a focus, then those possibilities are zero. That's just it. So Galileo changed the course of civilization. I don't expect that from any of us. I don't expect it. Why not? It could happen. I'm open to that. But I do believe that we are all, or I firmly believe that being able to think in more than one way is in and of itself valuable and worthwhile. So on Wednesday, I won't tell any more stories. We'll get right on Pearson. I'll have the registration information. We can get going. I'll look at we'll look at the way Pearson is organized, maybe even do the orientation exercise together. And then we'll start up with percents. Anyway, and I will see you then. And by the way, I spent some time with my son, and it was really valuable time. And there are things that are absolutely more important than coming to class. I'm sorry that I couldn't do both, but it was a scheduling thing that was out of my control. And just like when you make decisions that are that reflect your priorities in life, I honor that. So hopefully, and again, this is now, I did cover this as much as we could. We can't really do the Pearson together. That was my objective, is to do it together. So that can't be reproduced, but what can be done, we are responsible I am responsible for providing whatever input I can. And if it's going through a worksheet on another day when we're working on something and I'm not there, I'll go through the worksheet, go through all the details. And the same responsibility, the reciprocal responsibility for you is if something more important comes up in your life, you're not in class, then you go to Sakai, you get the worksheet, you work through it, you look at whatever notes I have provided, and there will always be a complete key so that you can um, go through as well as you can what we've done, then bring your questions in. All right, I will see you on Wednesday.